Hello, my name is Miguel Angel Lopez and I am going to explain the work that we present. This is the poster SG5 P052. In the present work, the results of the optical and structural characterization of a lead sulfide or PbS film and nanoparticles are reported. Both types of materials were obtained through the same synthesis process, using the chemical bed depositions, or CBD. As it is known, lead sulfide is a material with semiconductor properties that belong to groups 4-6. Some of the possible applications may be in the infrared range detectors and solar cells applications that could allow the use of the infrared spectrum of solar radiations. About the material and experimental part, the following reagents were used. As solution 1, lead nitrate at 0.17 molarity, solution 2, sodium hydroxide at 0.57 molarity, and solution 3, thiourea at 0.1 molarity. The solutions prepared were 20 milliliters, 50 milliliters, and 20 milliliters respectively. Next, solutions 1 and 2 were mixed. At this point, the solution turns white, as we shown in figure 1. Then previously cleaned glass samples holder substrates were immersed in these solutions. Solution 3 was subsequently added, causing the overall solution start to turn gray, as shown in figure 1 also. Finally, 20 milliliters of deionized water was added, and we count 10 minutes of reactions. Every experimental part was carried out at room temperature. The cleaning of the glass substrates was carried out as follows. They were first washed with water and neutral soap, then rinsed with deionized water, then immersed for 5 minutes in acetone under ultrasonic agitation, and finally in isopropyl alcohol for another 5 minutes, dry with nitrogen and stored for the reaction parts. As I say in figure 1, we observe the sequence of the experimental part and the samples that we obtained, a film and some nanoparticles. The formation of PbS particles is considered to occur according to the following reaction mechanisms. The characterization techniques. Samples were characterized by X-ray diffractions and characterized by using an spectrophotometer in the infrared region, which reveals an absorption range from 1600 nanometers to 1750 nanometers, as we show in figure 4. X-ray diffraction pattern on PbS also reveals that the formation of this compound corresponds to PbS. During this experiment, special equipment or conditions were not necessary, so this technique offered a cheap procedure to obtain some materials, in this case lead sulfide. In the same experiment, two kinds of materials were obtained, nanocrystals and film of PbS. Nanocrystals can be used to deposit a film by using drop coating or centrifugation technique. A glass substrate can be immersed in the beaker to form a film directly on the glass substrates. After washing the nanoparticles of PbS, they can be used to prepare an ink in order to try a printing technique. XRD structural characterization confirmed that the obtained materials correspond to lead sulfide. Nanocrystal size was estimated to be 12 nanometers according to the Devine-Scherrer equation. Finally, authors are very thankful to Polytechnical University of Guanajuato and Simvestab for materials, equipment, and the financial support to this project. Here we have some reference. Thank you very much.